Hey guys, what's up? Today is day 21, review. I'm going to do another video tomorrow that's also review. Today I'm going to be demonstrating problems 5, 12, 14, 18, 19, and 24 from the review packet, as I thought those were some of the more challenging ones on there. So we're going to look at those. If there's another problem that you want to see in the video tomorrow, please comment below. I know you all are subscribers, so you don't have to worry about that. But make sure you comment with which one you want to see, and I'll do it. Okay? If I don't get any comments about it, I'll just choose some other ones that are some of the more difficult ones. I also want to do one example of a problem of a graph. So let's take a look at this graph problem first that we're going to solve. Then after that, we'll look at those problems from the review packet. Again, if I'm doing problem 14, if you are really confident on problem 14, right, feel free to skip forward in the video to the numbers that you really want to see done. If you don't feel confident on any of them, make sure you watch the whole thing. Okay, but everybody should watch this one. Graph of f. Here's what we have. Here's our graph of f, made up of line segments. We need to know our axes numbers, right? So we'll say 1 here, 1 here. And here's what we have. Again, you can pause the video for a second to copy this graph down into your notes. Here's what we have. We have h of x defined as f cubed of x. And I want you to find h prime of negative 5. So go ahead and try this one. Pause it here. And then when you come back, we'll solve it. Okay, we're back. I want to find h prime of x before I even consider h prime of negative 5. So to do this, I want to think about what this really means. What does this f cubed x? That notation means the whole quantity f of x cubed. Notice that is not doing the derivative. That is simply rewriting h of x to be in a more derivative-friendly form. So I didn't call that h prime, I called it h. Now I want to do h prime of x. And again, what rule am I using? Well, the rule I'm going to use is the chain rule. So using this with the chain rule, I'm going to write h prime of x equals 3. I do the derivative of the outside with respect to the inside. So I keep the inside the same, and I have 3 f of x quantity squared. Okay, don't forget about that 2 up there. A lot of people are dropping that exponent of 2. Don't drop it. So we have 3 f of x squared. That's the derivative of the outside with respect to the inside. And then I got to chain on the derivative of the inside. So here's what I have. H prime of x is equal to 3 f of x squared times f prime of x. Now I got h prime x. Now I can go after h prime negative 5. Again, I'm just going to replace every x with a negative 5. So now I'm to a point where I'm going to have to start figuring out values from this. Notice I didn't even need to use the graph whatsoever to get to this spot. Now I need to figure out 2 things. I need to figure out f of negative 5, and I need to figure out f prime of negative 5. So let's go up to our graph and take a look. I'm going to count off negative 1, 2, 3, 4, 5. Here's negative 5. And again, I'm concerned about 2 things here. I'm concerned about f of negative 5, and I'm concerned about f prime of negative 5. F of negative 5 is what is the y value when x equals negative 5. F prime of negative 5 means what is the slope. So when I take a look at this y value here, right, I can see that, okay, my slope there, I dropped 1 and went right 2. So I know my slope is negative half. So every 1 I move to the right, I drop by half. So I went from 2, and I'm dropping by half. So I'm at 3 halves. So here's what I know. I know that f of negative 5 equals 3 halves. It's positive 3 halves because I'm above the x-axis here. What about f prime of negative 5? Well, f prime of negative 5 is simply the slope, right, of the tangent line. And since this thing is a line segment, it's just the slope of the line segment at negative 5. That slope, again, is negative because our function is decreasing there. We have negative 1/2. So I'm going to go ahead and plug those values in down here. So I'm going to get h prime of negative 5 equals 3 times f of negative 5, again, was 3 halves squared times negative half. Okay, so I'm now going to simplify this thing. 3 halves squared. Please remember your exponent rules, right? When you square a fraction, you square the top, you square the bottom. That's 9/4. So I have 3 times 9/4 times negative half. 3 times 9/4 is 27/4. Times negative 1/2, which gives me a final answer of negative 27/8. And there you have it. Okay, let's go ahead and start working on those review problems. The first one I want to look at is problem 5. Problem 5, again, if you're comfortable on problem 5, just skip ahead to the next problem. But problem 5, we want to do the derivative of x cubed minus 8, x squared minus 2. Okay, when we look at this one, right, I see a function, x cubed minus 8, times another function, x squared minus 2. So one way that this could be solved is we could solve this problem by the product rule. Okay, so let's try it this way, and then I'm going to show you maybe an easier way to do it as well. So to do this derivative then, we do the derivative, right? This is our first function, this is our second function. We're going to do the derivative of the first, which is 3x squared. Remember, the minus 8 is a constant, it goes away when we do the derivative. And now I need to multiply by the second function. Now notice this second function is a binomial. So I need to make sure it's in parentheses when I multiply. Plus the first function, x cubed minus 8, which again is a binomial, I want to put it in parentheses to multiply by the derivative of the second, which is 2x. Now, since this wasn't a multiple choice problem, we are at the derivative right now. We can stop right here. But taking a look at this thing, right, I could also simplify this by distributing that 3x squared and distributing that 2x. And what I end up with is 3x to the 4th minus 6x squared plus 2x to the 4th minus 16x. When I do this, I see like terms here and here. And I can say, oh, 3x to the 4th plus 2x to the 4th, that's 5x to the 4th. I don't have a like term with my x squared or my x. So I can get to here. The other way I could do this problem is I could have just FOILed right at the beginning, right? Let's see if I get the same answer using the power rule. Oops. If I FOIL this thing at the beginning, I get x to the 5th minus 2x cubed minus 8x squared plus 16. So if I do the derivative of this, I no longer need to use the product rule. I can simply go through and do my derivative, and I'll get 5x to the 4th minus 6x squared minus 16x. And I look, do they match? Yep. They do match, therefore I got it. So that one I highlighted because there's another way to do it. All right, let's flip to problem 12. I'm asked to find f prime of x here. I highlighted problem 12 because, as we can see, we have a function, e to the 3x, times another function, sine of 4x. So clearly here we need to use the product rule. But both of those functions, e to the 3x and sine of 4x, are compositions of functions as well. So when I do their derivatives, I need to do the chain rule. Okay? But we're doing the chain rule whenever we have to, but we're doing this in the framework of the product rule. The product rule says we do the derivative of the first times the second. However, that derivative of the first is going to require a chain rule. So the derivative of the first, the derivative of e to the 3x is e to the 3x times 3. The derivative of the outside with respect to the inside is e to the 3x, but I have to multiply by the derivative of the inside. The derivative of 3x is 3. I have to do the chain rule with e to anything other than just regular old x. So that's the derivative of the first, and now I have to do times the second, times sine of 4x. So this is the derivative of the first times the second, plus the first, e to the 3x, times the derivative of the second. Well, that derivative is a chain rule, right? Because I have a function 4x within another function sine of x. So I do the derivative of the outside with respect to the inside times the derivative of the inside. What's the derivative of 4x? Well, that's 4. If I don't chain on that 4, this answer is not correct. All right, I'm just going to clean this up a little bit and write my coefficients out front. So I'm going to say this is 3e to the 3x sine of 4x plus, I'm going to put this 4 out front, 4e to the 3x cosine of 4x. And I'm done. Let's take a look now at problem 14. 14 said f of x equals cosine squared of 6x plus 5. I highlighted this one because this is a double chain rule kind of a thing, right? Chainception or two chains. So it might help me to rewrite f of x, right? When I see that 2 in between the cosine and the 6x plus 5, that means the whole thing is being squared. So I'm going to write this as cosine of 6x plus 5 squared. And now I have a function, 6x plus 5, within another function, cosine of x, within another function, x squared. So I want to do the outermost derivative first. I'm going to do the derivative of the outer function with respect to the inner function. Now you don't need to write that power of 1 up there, because we don't need to write to the first power. I just want to put it there so we're conscious of it and remember it. Right? If it was cos cubed of 6x plus 5, it would be 3 cosine of 6x plus 5 squared. Okay? That's the derivative of the outside with respect to the inside. Notice I didn't change anything about the inside. I just did the derivative around it, kept the inside the same. Now I need to multiply by the derivative of the inside, which is cosine of 6x plus 5. Well, that in itself is a chain rule problem. So I multiply by the derivative of the outside, which would be negative sine with respect to the inside. And then I need to times by the derivative of the inside, which is 6. So again, I did the derivative of the outside with respect to the inside times the derivative of the inside. Well, that derivative of the inside was another chain rule. So I did the derivative of the outside with respect to the inside times the derivative of the inside. Clearing this whole thing up. My 2, my -1, and my 6 are all coefficients. I'm going to multiply them together to make -12. Cosine is 6x plus 5. Sine is 6x plus 5. And that's my answer. Okay. Let's flip to problem 18. I have y equals ln of 4x squared minus 1. I want the equation of the tangent line. I want equation of tan line at x equals 1. And anytime I have an equation of a tangent line that I'm trying to find, I need to consider a point and a slope. Instead of always just doing the derivative right off the bat, it's a good idea. Anytime you see equation of a tangent line, write those two things so you don't forget to do it. A lot of people miss points on the test because all they found was the slope of the tangent line, right, without considering the point and writing an equation of a line. So if we do that right when we see that word equation of a line, we'll help prevent that error. Now I know one part of the point is 1. That's the x part. I gotta then plug in 1 to find the y coordinate of the point. Well, when I do that, then I'm doing y of 1. That's the natural log of 4 times 1 squared minus 1, which is ln of 3. Because ln of 3 doesn't simplify nicely, I'm just going to leave it as ln 3. The only natural logs that we need to really simplify are ln 1, we should immediately know as 0. Ln e we should know as 1. And ln of e to any power is just that power. But ln 3 is just going to be plain old ln 3. Next, I need to find the derivative, and then I need to plug in 1. Oops, I need to plug in 1 into my derivative. So let's find dy dx. Well, this is a chain rule problem. So when I do the derivative of ln of 4x squared minus 1, that is 1 over, I know ln x is 1 over x, so ln stuff is 1 over stuff. And now I need to multiply, don't forget to chain on the derivative of the inside, which is 8x. Which simplifies to 8x over 4x squared minus 1. Please do not reduce that 8 and that 4. That minus 1 prevents us from doing it. Can't do it. Okay, now I'm just going to plug in 1 in for x into my derivative to find the slope. So, dy dx, I want to evaluate that at x equals 1. So that's going to be 8 times 1 over 4 times 1 squared minus 1. So on top I get 8. On the bottom I get 4 minus 1, which is 3. So now I know my slope is 8/3. Therefore my equation is y minus ln 3 equals 8/3 x minus 1. Okay. Let's take a look at 19. Says h of x equals the arc sine of 3x to the 4th. Find h prime of x. Well, I need to know arc sines of x's derivative in order to do the arc sine of 3x to the 4th. Arc sine's derivative was in the video from yesterday, right? That's 1 over the square root of 1 minus x squared. But this is a chain rule problem because I have a function, 3x to the 4th, within another function, arc sine of x. So h prime of x is going to be 1 over, instead of the square root of 1 minus x squared, I'm going to do the 1 over the square root of 1 minus 3x to the 4th squared. Right? This is the derivative of the outside with respect to the inside. And then I need to multiply by the derivative of the inside. Make sure this is not going on into the denominator, right? We're multiplying by the derivative of 3x to the 4th, which is 12x cubed. Again, this is sufficient for a correct answer. Cleaning this up a little bit, how it would look on multiple choice, it would look like 12x cubed over the square root of 1 minus 3x to the 4th quantity squared is 9x to the 8th. This is how it'll look in the multiple choice. Okay? The last question I want to look at in this video is question 24. 24 is difficult because it's multiple choice. It's also difficult because we have a couple of different rules going on. So what I see here is a function, x over x plus 1, within another function, x to the 5th. This can be done a couple of different ways. Okay, I'm going to do this one via the chain rule to start. I think it's probably easiest using the chain rule. So I'm going to do the derivative of the outside with respect to the inside, and then I need to multiply by the derivative of the inside. So the derivative of the outside with respect to the inside looks like this. But I got to chain on the derivative of the inside. Well, to do the derivative of the inside, I need to use the quotient rule. So the quotient rule says I do the derivative of the top. The derivative of x is 1 times the bottom, x plus 1, minus the top times the derivative of the bottom, all over the bottom function squared. Now, this is the correct derivative. This is the correct answer. Here's the problem with multiple choice. That doesn't look like any of my options. Okay, so we're going to need to simplify this thing. This is why I want you to practice simplification. Okay? Let's start with that x over x plus 1 to the 4th. Right? Anytime I have a fraction to a power, it's the top to that power, the bottom to that power. So I'm just going to say this equals 5 times x to the 4th over x plus 1 quantity to the 4th. Okay? Also, up here, this top turns into x plus 1 minus x, which simply simplifies to 1 over x plus 1 squared. Now I'm going to multiply these three fractions together. When I do 5 times x to the 4th times 1, I get 5x to the 4th. When I multiply 1 times x plus 1 to the 4th times x plus 1 squared, I get x plus 1 to the 6th. And that leads me to answer choice C. That is it for today. Maybe tomorrow, this video is already getting kind of long. Tomorrow I might show you a different way to solve 24. That's it. Have a good one. Study hard. Remember, make sure you ask any questions that you want to see, any problems you want to see. Post them in the comments and I'll do them in the next video. Thanks. Outro.